In 1971, psychologist B.F. Skinner ran a deceptively simple experiment. He put a pigeon in a box with a button. Press it, get food. But then Skinner changed the rules. He made the button unpredictable. Sometimes pressing it delivered food, sometimes it didn't. The pigeon learned that the outcome was a mystery, so it began pressing the button frantically, over and over. Skinner had discovered that unpredictable rewards are far more compelling than guaranteed ones. Fast forward to today. The average person now checks their phone 96 times a day. We swipe and pull to refresh, in the same compulsive manner as that pigeon, waiting for an unpredictable reward. Social psychologist Jonathan Haidt has compiled data showing that this behavioral loop is directly correlated with population-level spikes in adolescent depression and anxiety. This chart shows the collapse of human attention over the last 2 decades. In 2004, the average time a person spent on a single screen before switching was 2.5 minutes. By 2020, that number dropped to just 47 seconds. This compulsive checking is the intended outcome of an engineered feedback loop that scales Skinner's discovery to billions of human users. To see how those feedback loops are built, we look to Stanford researcher B.J. Fogg, who identified the invisible triggers behind our behavior. Fogg developed a simple equation, B equals MAP. A specific behavior only occurs when motivation, ability, and a prompt converge at the exact same moment. Social media platforms focus on the motivation variable by targeting the brain's dopamine circuitry. Dopamine is not actually the chemical of pleasure, it is the chemical of anticipation. It generates the sensation of wanting. Your brain releases it when you suspect a reward is coming, not when you actually receive it. This is known as variable ratio reinforcement. Because you don't know what a notification holds, a message or a viral post, massive dopamine spikes occur before you open the app. The adolescent brain is uniquely vulnerable here. Their reward sensitivity systems are fully active, but their prefrontal cortex, responsible for regulating impulses, is still developing. Tech companies have engineered a digital environment that maximizes biological motivation against an ancient neurological system. The smartphone also maximizes ability. Because the device lives in your pocket and is always logged in, the behavior is nearly effortless. Then there is the prompt. Every vibration, red badge, and push notification acts as an inescapable trigger to start the behavior. Completing this equation dozens of times a day creates attention residue. When you switch tasks to check a notification, your brain doesn't make a clean cut. Part of your cognitive processing stays stuck behind. After checking a brief notification, it takes the human brain an average of 23 minutes to fully re-engage with deep work. Multiplied across an entire day, these constant interruptions mean we spend more time recovering from task switches than we do on focused thought. The modern smartphone executes the BMAP equation so efficiently that it leaves little room for the neural networks required for sustained concentration. Fogg's research shows motivation naturally fluctuates like a wave, with high peaks and deep valleys, making willpower a mathematically unreliable defense against an algorithm. To change the outcome, you must manipulate the other 2 variables, making the behavior difficult and eliminating the triggers. Minimalist technology, like the light phone, is a physical hardware intervention designed to break the B equals MAP equation by force. It removes the ability to get distracted by stripping out app stores and infinite scrolling mechanisms. It also removes the prompts by preventing algorithmic push notifications from reaching the user. This hardware breaks the behavioral formula by making distraction difficult and keeping the notification silent. Our current distracted state is not permanent. Through neuroplasticity, the brain is constantly forging new connections based on the demands we place on it. By using digital detoxes or tools that measure our focus states, we can train the prefrontal networks that have weakened. When we cut off the constant drip of variable ratio rewards, the brain can physically rebuild gray matter in the prefrontal cortex within weeks. Every piece of technology shapes the brain that uses it, but we are not destined to remain inside a feedback loop we didn't design. By deeply understanding the behavioral equations used against us, we can redesign our tools and finally reclaim our cognitive freedom.